Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy.
Astronomers have just peeled back a dramatic new layer of our cosmic history. And what they found isn't the peaceful picture we once imagined. Thanks to the James Webb Space Telescope, a team from the University of Cambridge has uncovered that the early universe wasn't calm or organized at all. Instead, it was a storm of chaos, galaxies colliding, gas swirling, stars bursting into life, all within the first billion years after the Big Bang. Imagine looking out into deep space, expecting elegant spirals like our Milky Way, but instead finding something wild, clumpy, and unstable. That's exactly what Webb revealed. Using its NIRCam instrument in a special GRISM mode, scientists were able to peer inside more than 250 young galaxies, catching faint whispers of light from ionized hydrogen, the telltale sign of star formation. For the first time, they could trace how gas was moving inside these galaxies, and what they found completely rewrites our understanding of cosmic evolution. Rather than smooth rotation, most galaxies looked like they were locked in cosmic turbulence. Gas and dust whipped in every direction, forming strange, uneven shapes. Only a small handful showed the early signs of rotating disks, the kind that would later grow into the graceful spiral arms we see today. It turns out that the beautiful order of the modern universe emerged from pure disorder. This isn't just a few rare outliers, explains Lola Danhive, lead author from Cambridge's Kavli Institute for Cosmology. We're seeing an entire generation of galaxies caught in the act of forming, and most are still chaotic, gas puffed up, moving everywhere at once. Her words bring to life a young universe in motion, restless and raw. For decades, astronomers debated whether galaxies formed quickly into neat rotating disks or evolved slowly through turmoil. Webb's observations have finally tipped the scales. Chaos came first. Early galaxies were rich in gas, prone to violent mergers, and bursting with newborn stars, a recipe for turbulence. Each collision disrupted their structure. Each new star injected energy, stirring the galactic soup even more. Co-author Dr. Sandro Tiscella puts it simply: when you look at hundreds of smaller galaxies instead of just a few massive ones, you start to see the truth. The early universe was messy, unstable, and alive with collisions. It's a shift that brings theory and observation closer together than ever before. The study, published in the monthly notices of the Royal Astronomical Society, marks a huge leap in understanding how galaxies like our own came to be. It bridges the timeline between the epoch of reionization, when the first light broke through cosmic darkness, and cosmic noon, the peak of star formation. Somewhere in between, these unruly galaxies began to settle down, cooling and flattening into the calm, rotating disks we recognize today. And yet, this is just the beginning. The team plans to combine Webb's data with future observations of cold gas and dust, the real building blocks of stars, to uncover how these turbulent galaxies finally matured. As Tiscella puts it, we're watching the universe grow up. With more data, we'll be able to trace how chaos turned into order, how those early storms became the graceful spirals we see now. When the James Webb Space Telescope, JWST, collects data, it doesn't just take breathtaking photos, it also breaks down light into its individual wavelengths using small optical devices known as grisms, or grating prisms. Operating between 2.4 and 5.0 micrometers, these tools allow Webb to perform slitless spectroscopy, which captures the infrared fingerprints of distant objects. This helps astronomers decode the chemical makeup of stars, exoplanets, and galaxies billions of light years away, revealing what they're made of and how they evolve. Beyond exposing the chaotic youth of galaxies, Webb has transformed nearly every field of modern astronomy. One of its most astonishing achievements came from the first deep-field images, showing galaxies that formed just a few 100 million years after the Big Bang. Some of these galaxies were far more massive and luminous than models predicted, evidence that the early universe was building structure much faster than anyone thought possible. This single observation challenged long-held ideas about how quickly stars and galaxies could emerge from cosmic darkness. Webb's gaze didn't stop there. Turning its instruments toward exoplanets, it captured the most detailed spectra ever obtained from worlds beyond our solar system. Scientists detected water vapor, methane, and carbon dioxide, revealing atmospheres far more complex than expected. One remarkable case is K218b, a Hycean planet where Webb detected dimethyl sulfide, a molecule that on Earth is produced only by life. While not definitive proof of biology, it's one of the most intriguing signs yet that habitable environments could exist elsewhere. Webb has also given humanity an unprecedented window into the birthplaces of stars. In regions like the Orion Nebula and the Pillars of Creation, its infrared vision peers through the dense dust that once hid these stellar nurseries, capturing young stars still wrapped in their cosmic cradles. These observations reveal how stars ignite, interact, and sculpt the space around them, the very processes that lead to planet formation. Even more astonishing are Webb's images of protoplanetary disks, swirling rings of dust around young stars where new planets are being born. In some of these disks, scientists can literally see the gaps and rings carved by forming worlds, a cosmic snapshot of solar systems under construction. Closer to home, Webb has turned its powerful lens toward our own solar system. It has observed the shimmering rings of Saturn, the icy blue clouds of Uranus and Neptune, and even the chemical composition of comets and asteroids, helping astronomers understand the ancient ingredients that built our planets. But beyond the data, Webb's greatest accomplishment may be how it changes our perspective. It reminds us that the universe is not a quiet, predictable place. It's alive with motion, energy, and transformation. Every image Webb captures is a window into our origins, a look back billions of years to the moments when galaxies, stars, and planets first took shape. And lastly, the journey isn't over. Scientists are already planning to push further back in time, closer to the first few 100 million years after the Big Bang, to witness the very birth of galactic structure. The goal? To discover exactly when and how the universe shifted from chaos to order. As Takela put it, this is just the beginning. Each new Webb image is another step in tracing how violent, turbulent systems matured into the elegant spirals that now grace our night sky. The early universe wasn't peaceful. It was loud, unstable, and alive with motion. But out of that cosmic storm, beauty was born. The early universe, it seems, wasn't a quiet nursery of galaxies. It was a cosmic battlefield, and Webb just gave us front-row seats. It turns out that the early universe didn't give rise to perfectly formed galaxies overnight. It took time, collisions, and a whole lot of cosmic chaos. Only a handful of galaxies captured by the James Webb Space Telescope showed hints of rotation, suggesting that the formation of stable disks was a slow, gradual process. As galaxies accumulated mass, their gas cooled, and violent interactions began to subside, structure slowly emerged from disorder. Co-author Dr. Sandro Tiscella explains that past studies often focused on a few bright, massive galaxies, outliers that made the early universe seem more organized than it really was. But when you zoom out and examine hundreds of smaller galaxies, the story changes. The early cosmos wasn't calm. It was a storm of creation, where turbulence reigned and order was still a distant goal. These newly observed galaxies bridge two of the most dramatic eras in cosmic history, the epoch of reionization, when the first galaxies lit up the darkness, and cosmic noon, the period when star formation reached its peak. What Webb has captured are galaxies caught mid-transformation, evolving from chaotic clouds of gas into the first hints of stable rotating systems. This discovery doesn't overturn our theories, it confirms them with a clarity never seen before. Galaxies weren't born graceful, they became that way through centuries of cosmic struggle, and the implications are vast. First, it reshapes how we model galaxy evolution. Scientists now know that instability lasted far longer than once thought. The idea that galaxies quickly settled into tidy disks doesn't hold up. Instead, turbulence, mergers, and feedback loops were the dominant forces for much of the universe's early history. Second, Webb's extraordinary sensitivity opens a new frontier for astronomy. For the first time, researchers can study entire populations of galaxies, not just the spectacular few. This means scientists can now investigate how cold gas and cosmic dust behave alongside these turbulent systems, the raw ingredients of stars and planets. By piecing together these datasets, astronomers will finally understand how galaxies made the leap from chaos to stability. Third, these unruly galaxies may offer a window into our own Milky Way's past. Billions of years ago, it too may have been a messy, energetic cloud, its gases colliding and swirling as stars formed in bursts. Looking at these distant galaxies is like opening a time capsule, showing us how our home in the cosmos came to be. Over time, galaxies have trended toward order and calm, according to the Cambridge researchers. Yet in the beginning, the cosmos was anything but peaceful. Frequent bursts of star formation and gravitational instabilities stirred up immense turbulence, leaving young galaxies in a state of constant upheaval. We don't just see a few spectacular outliers. This is the first time we've been able to look at an entire population at once, explained Lola Danhaive from Cambridge's Kavli Institute for Cosmology. We found huge variation. Some galaxies are beginning to settle into ordered rotation, but most are still chaotic, with gas puffed up and moving in all directions.